Mm, it's 10 Science news, science news, science news. Everybody loves some science news. Or maybe not. But it sucks. Maybe when it starts to actually collapse, politicians will start taking change seriously. I mean, when I bought my house, I took sea level rise into account. So I just I just assume sea level rise is going to have to put major city or two underwater. Start taking it seriously. wonder whose sequences they decided to put on the crystal. The holographic storage is interesting. It works kind of the same way as like a DVD or a Blu-ray disc, but it has multiple layers, so you got it more observable. It's very dense storage. It sounds like this is kind of based on that, except maybe it's some difference from the substrate. Because the plastic that you use for a typical disc will not last that long. That's probably some sort of quartz crystal. Yep. If you depend on wind for your motion, ship, these areas are really dangerous. Gotta be careful. But these days we use oil-based engines to power our ships, usually, so wind speed is not as big a deal. It's still more efficient to put the wind behind your ship. Sailing directly into the wind is a little bit less efficient. We have some new designs that we're testing out to use the wind to reduce fuel cost. So the old view was maybe the air is getting sucked up into storms. The new view is, it's actually big blobs of dense air that are just kind of settling down instead. guess this paragraph makes sense. You can only converge air for so long. It has to go somewhere. I mean, it can kind of go up and out the top and spread out to the sides, but that's kind of the main pattern. Why it's a good idea to occasionally go back and just rethink old ideas, because these days we have a lot more data. We have buoys all over the world, and we have also commercial ships tend to record this data and put it in databases that people give access to. If you want to research it, they keep track of things like surface temperature and wind conditions. Plus, we have satellite weather data. Interesting. These analogies just keep getting weirder and weirder. Bolts fired at Mars. Nice. Firing black holes at Mars. This one seems like the most realistic title. How to spot tiny black holes that might pass through the solar system. Okay. That's a real title that suggests an actual article. Measuring the weight of the W boson. You can see that. Not sure how this got put in this bucket. This is a totally different bucket. From leaf decay. Sure looks cool. Yeah, okay, that makes sense. It's the oil in the leaves. It's kind of like an oil slick in a parking lot. So this is thin film optics. So when you have a thin film on top of the liquid, right, then part of the light gets reflected off of the film, and part of it makes it down to the second layer and gets reflected off the boundary between the oil. In this case. Right, so now you have two beams of light that are very similar, slightly offset from each other, so they cancel out. different colors cancel out at different distances. That's why the ones in the background look more yellow and the ones in the foreground more blue. Although it's a little odd to get color gradient of purple. It's blue and violet are on one end of the spectrum. Red is on the other end. With this pinkish color, it's kind of not a real color. It's actually two colors. Yeah, we're getting more than one, basically more than one rainbow. So it looks like it's purple here, and then it goes, right, it goes to red, and then it goes up to the green again. It does a second cycle. So this kind of pinkish color is like a mixture of the violet and the red. This is the color that we perceive when our eyes get violet and red, but no green light. Might be a little bit tricky to go see it in person though. So kind of a fragile effect. Funny, mysterious, large-scale structures found hidden beneath ancient lost ocean islands. It's a rehash of an article from a couple of weeks ago. It's a little bit bombastic. We're talking geological structures here. The ocean's not really lost, it's just kind of dried up because Mars doesn't have an atmosphere conducive to retaining water. So, I mean, the main problem is it's just not big enough. It's kind of why Mars is never going to be Earth 2.0. It's just not big enough. It means it doesn't have enough gravity. It has trouble holding on to its atmosphere. And it's probably not enough gravity for humans to stay healthy in the long term. And it would be tricky to increase its mass by enough. Like even if you collected most of the asteroids in the solar system, that would not be enough. You would have to go and grab moons. We could. So the sun and the gas giants, right, are clearly in the lead. Then of the terrestrial objects, right, Earth is the biggest. Right, and this is why Venus may be a better long-term project. I mean, the fact that it's boiling hot and poisonous is something we'd have to deal with. Right, here's Mars. Mars is only about half of an Earth. Right. And I'm not sure that's enough for healthy humans. It's definitely not quite enough for a stable atmosphere. Right now, if we ground up like Ganymede, Titan, Mercury, Callisto, Io, Europa has a bunch of water. Right, so it might be a good choice. Or we could collect like all of these. Right, but we kind of don't want the blue ones because they're really far out. A bit of a pain to collect. On the other hand, things that are smaller are easier to grind up and shoot out of a mass driver. For the record, doing this would totally mess up Mars for quite a while, right? We'd have to wait for everything to melt together and settle again. Crash this much mass into a gravity well releases a lot of heat. On the other hand, Mercury is probably not a great option. Yeah. I mean, we can't live there because it's too close to the sun. The weather is actually that's half true. I believe Mercury is tidally locked. The same side faces the sun. So we could live in the twilight zones. The side that faces the sun is too hot. The side that faces away from the sun is too cold. We could theoretically land stuff on the area like right around the edge where it doesn't really have sunrise. The tidally locked systems don't have sunrise and sunset. Kind of have sun on the horizon all the time. Yeah, I guess another interesting option might be crashing all of Jupiter's moons into each other, right? Because they're all pretty big. Or, I mean, not, maybe not all of them, but the biggest ones. Then you kind of end up with a weird situation where you, like that far out, the sun is not that bright. So a lot of the incoming energy on Jupiter's moons is radiation from Jupiter. So I kind of wonder how that would work out. But yeah, they're pretty frozen. I don't know, but maybe like if you clubbed together enough stuff to make it bigger, would that increase? Yeah, that would increase the effects of tidal heating. But that's why there's a theory that Europa actually has it's ice on the surface, but there's theory that it might be actually liquid water underneath. But that's due to tidal heating. In other words, the gravity from Jupiter being so close stretches and squishes its moons as they spin. So they have really strong tides. But stretching and squishing like that can generate. Yeah, if we wanna live on a planet or moon or in anything really, right? For the long term, it's much more reasonable if it's big enough to hold on to its atmosphere, and warm enough that we don't have to find a way to artificially warm that atmosphere. Right, having a deeper atmosphere does help. The more atmosphere you have, the better it's on. We want to be careful about so one of the options is we can do on purpose what we're doing accidentally on Earth and introduce greenhouse gases into the atmosphere. Assuming you have something that's big enough to hold on to it. Other than Earth. It's, it's kind of a neat picture. beautiful picture of the Earth and the Moon. In case you can't tell, the sun is at the top of the picture, but much farther away. You can tell, but this is the side that's shiny and bright. It's funny, you got a gibbous Earth and a gibbous Moon. Can't tell for sure which part of the Earth this is showing us. Right, based on the axis of rotation, right? The poles need to be up here where the light and the shadow come together. This was taken in September, and then the axial pole is going to be pretty much right there where the boundary is. This is going to be, I think probably this is the North Pole and that's the South Pole. This is maybe Europe, Greenland, North America, South America. Hard to tell with the cloud cover. Right. This is what I always say. The Earth's moon is relatively quite large. Most moons are not. Right. They're not proportionally this large compared to their planets. It's also a little farther away than you might think. That makes sense. The moon is actually closer than the Earth in this picture. Right? Otherwise, it would look like the moon was really far south. It doesn't. It's not actually that far south. It's closer than it appears. with black holes. Yep, that could happen. It's possible there's a lot more black holes than we know about. They're hard to see because they're black. This is interesting. Right, we've known for a while that rubbing two objects with different electronegativities together causes electrons to go from one to the other. Like, the actual mechanism of the why has been a little bit I think they're probably overstating this when they say, and we uncovered the mechanisms at play. That's a very strong statement. I would suspect, and we'll find out in a minute, but I would suspect that this research project has provided some evidence for one or more mechanisms that may contribute. Right, it's a much weaker statement, but more likely to be true. Kitty. So, I kind of want to know exactly what he means by having different affirmations. Bending tiny protrusions on the surfaces. Kind of, this is a question of if you made surfaces sufficiently flat, would they form a static charge when you rub them together? That's what I would try. I would try and see if I could make two surfaces flat enough. I mean, at that level, I'm talking flat enough that none of those forces get involved. Yep. Dust is important. Provides nutrients for microorganisms. Still recycling this. Testing out the radiation shields. You gotta. Because the sun is a deadly laser. This makes sense. Walking without thinking about it. Definitely not the front part of your brain. Maybe what they didn't tell us is where the control of the light is coming from. I would So we do kind of have a cluster of nerves towards the base of our spine that coordinates a lot of our lower body functions. So it could be that, or they could be using brain in a non-standard way in this article. It's saying the forebrain, the thinking part of the brain, or even the middle part of your brain, which is usually muscle control. It's kind of separate from the back part of your brain, which is usually in charge of things like breathing and heartbeat. The farther forward in your brain you go, the more it's a piece of your brain that you consider you, if that makes sense. The stuff at the back of the brain is more automatic. Also, a lot of our eyesight is in the back of our brain. Hearing and language are to the sides. We don't really think about those. Smell is mostly on the bottom, just for proximity to the nose, I suspect. It's interesting. I wish the article had a little bit more information on where the actual control systems are located. As I said, the brain isn't exerting deliberate control. It's a gut feel, but then what is? This is a good Tetris title. So this is a rehash of the Waterflea articles. This article also seems to have a subtle misreading of the Waterfleet study. It's, if I remember what I read about the Waterfleet study correctly, um, one of the big things that the Waterfleet study was doing was minimizing external selective pressure. Right, so what they were actually studying was if you take away the whole survival of the fittest thing, right? If you take away fighting for resources and you keep the water fleas in an ideal-ish environment for them, what happens? So, and also, this is the same old absence of evidence is not the same as evidence of absence, right? Just because your study doesn't, you know, prove something doesn't mean that that thing is wrong. The flip side is that we've known that Darwin's version of evolution is not that great, honestly. Like, core idea that traits can vary across a species, right? And traits that are particularly beneficial tend to get passed down more, right? That's basically the whole, like, out of all of Darwin's work on the topic, that's the part that was best. Right? How different traits arise is something we've known for quite a while. It's not as simple as Darwin proposed it was. This is interesting. Yeah, so C. elegans is a species that we use in a lot of studies because they don't have that many genes. So we've studied them pretty thoroughly. And since we understand them pretty well, since they're simple enough that we can understand them reasonably well, we can run studies on them, see how changing things affects the organism as a whole. Let's see. Florida Atlantic University's Schmidt College of Medicine. FAU Styles Nicholson Brain. I don't know what FAU is. I wouldn't. Oh, probably also Florida Atlantic University. So, Schmidt College of Medicine and Styles Nicholson Brain Institute, both at Florida Atlantic Universities. I would have taken the FAU acronym, put it over here, parentheses, so that when it showed up here, people would be like, oh, that's the same, two departments in the same university. Yeah, copper is kind of tricky as a nutrient for humans. little bit, and I mean a little bit, is good for us. And a lot is fairly bad. Right? And a medium amount is up in the air. Right, so there's currently a lot of people researching whether, so as a for instance, copper pipes are not that big an issue because they generate a passive oxidation layer. Right, they're exposed to the water and the chemicals in the water over a long period of time. Right, so all of the copper on the inside of the pipe has already reacted. Right, so there's no new reactions going on. So there's studies that are more interested in other uses of coppers, like copper kettles for cooking. Copper is a better heat conductor than steel is. So we use it in things like candy making because you need to distribute the heat evenly throughout the sugar. And that doesn't seem to be a huge problem as long as you're not scouring your copper kettles in such a way that releases copper into the food. When you clean it, you need to clean it in a way that doesn't mess up again, over time, the surface of the copper reacts and forms a neutral layer. But if you hit it with like steel wool every time you use it to make it shiny, then you remove that layer and then it has to react again. So when you're using copper cookware, if you want it to be shiny, you can scour the outside, but don't scour the inside if you can help it, right? Because that kind of the bright copper color, right? That kind of reddish orange color that copper turns when you polish it, like that means that there's no passivated layer on the outside. Yeah, kind of dull brownish color. It's the passive layer. So you don't want to mess that up on the inside. You want to leave the inside of your cookware brownish color. You can polish the outside if you want, but it doesn't touch the food. Where people have really been running into trouble is there are a couple of alcoholic beverages that I can't remember the name of off the top of my head. It's a combination of there's a couple of alcoholic beverages that are traditionally served in a copper cup. Combination of cleaning the cups and then filling them with alcohol causes an unsafe number of copper ions to be released. And there have been people who have run into trouble there by ingesting too much copper, getting dissolved into their booze, basically. Yeah, so the balance line is lower than you might think. It's definitely not like chunks of copper. You might think, that's silly, why would anybody eat chunks of metal? But we do that with iron. Like, when you eat food that has supplemented iron in it, fortified with iron, really is basically just iron dust being added to the food. But iron is not as dangerous to us. So. A lot of times whether or not something is dangerous depends on whether or not our bodies can get rid of it. The flip side, you can overdose on iron as well. some people are always short, some people have too much. If you're prone to iron deficiency or what's it called? Not having enough blood. I forget what it's called. I should wait for that. I think you probably need more iron. If you don't, then you probably, well, if you eat a typical American diet, you probably need less iron. Right. Typical American male, in particular, they don't lose that much blood. They eat a lot of red meat. Probably too much iron. You should give blood. It's actually good for you. At least in the sense of iron balance. Losing blood is one of the ways that the human body can balance its iron, right? Because hemoglobin, the molecule that binds oxygen in our red blood cells, has a lot of iron in it. Relatively a lot. But we were talking about copper. Let's see. SWIP10 gene in glial cells. Glial cells are part of like nerve function. I don't remember exactly what they do. Let's see. The SWIP10 gene plays an essential role in homeostasis copper 1 form. So when you get an element followed by a Roman numeral like that, it's just telling you its ionization state. So a 1 means that it's off by 1 electron. Right? It's in imbalance of 1. Let's see. Deleting SWIP dropped copper levels. Interesting. Causing energy deficits because mitochondria don't happen. Let's see, so here, copper, I assume that increasing copper 1 levels was done via supplementation. We're turning this with 10 back on. Interesting, interesting. This is probably not a nutrient you should attempt to supplement. I know, I know some people really love their supplements, but your body does a pretty good job of taking the copper from your food and storing it and balancing it in a way that's useful. Like I said, it's easy to do too much, right? If you scour your cup and fill it with your alcohol, you can get too much. Identified similar human gene that does show a risk for neurodegeneration problems in humans. It's an enzyme that helps produce histones, which, among other things, convert between the two forms of copper. So if you don't have enough of those conversion histones, then your body can't convert, which means it's going to have trouble balancing. My guess is that one of those forms is easier to store. Maybe the copper 2 ion is easier for the body to store, so it would rely on converting copper 2 into copper 1. Interesting. Interesting. I hope they keep working on that, because that seems like it could be useful. Seems useful. This one simple trick, lower your city's temperature. Yep. Reflective roofs. Makes sense. Lighter colored pavement would help too. The kind of tar-based blacktop that at least the US tends to use, right? Because it's cheap. It absorbs light really well. Yeah, this is funny. The description of a solution in search of a problem. It's a funny description of this. Yeah. Vortex rings are cool, and electromagnetism is cool too. And now we can use this device to create vortex rings in an electromagnetic field. I don't know what we would use that for. This whole paragraph says, made a special antenna, create a vortex, and the vortices are pretty stable. Tend to be like the theoretical version. I can only simplify it a little bit. I'm sure they put a lot of effort into getting the antenna just right. This is news and almost certainly not science news. I feel bad for you. That's not. It's not great. A single anecdote informed me in a way that is useful. Probably not, because if I was riding an electric scooter, I never actually have. I have ridden regular scooters. And if I was riding an electric scooter, I suspect I would be fairly careful. I don't know. Um, don't have your pertussis vaccine. Go get it. I think cough is really unpleasant. Just saying. Should avoid catching that one. Oh, I've got it up on the table now. Cool. Sleep and striking. Striking. Yeah, yeah, yeah. You asked him for something. Probably not food at the same time, though. Now that I told you I'm not going to give you anything to eat, well, you're interested. He always tries acting cute first. I'll wait too long and start coming up and poking me in the side. Comes up to the side of the chair and sneaks up and poke, poke. It just can go get all your vaccinations. Seriously. They are so much safer than the diseases. Yeah, this frustrates me. Vaccines should be free. Like, period. All of them. All the time, forever. Like, that's this is something the government should pay for. like, like, disease resistance should not be separated by class because it does not respect bank account. Right? So if poor people get sick, it will spread to the rich people. There's a clear set of reasoning to paying for vaccines for everybody all the time, no matter how to treat and prevent these really common infections that cause cancer. Doctor explains that article. It'd be nice if we had an Epstein-Barr vaccine. It's also known as mono. Right, we have one for chickenpox, which is related, but not for the rest of that family of viruses. Yeah, you should have your HPV and your hepatitis vaccines. Okay. Yeah, so the answer is get all your vaccines once again. One transformed his body. 2 diet changes and 1 simple workout. So the diet changes is probably eat a healthy diet, and 1 simple workout technique is actually work out. Yeah, so the main difference between those 2 pictures is he's lowered his body fat percentage. Right? You can have big muscles, but if you have a big layer of fat on top of it, you can't see them. So he lost some weight. I would guess that he worked out reasonably often before that. Yeah. And you should mix up your cardio and your weight training. You should do some weight training. Not a lot, you don't have to do a lot. You can do a lot. You need to have both. So these have been recycling for several weeks now. Yes, some diabetes drugs, about healthier glucose metabolism, which interestingly is related to that copper article that we were reading earlier. Because the copper was also, in that case, being used to change the glucose into ATP. Right? So, like, these are all lining up. Well, so genetics is going to determine whether or not a kid likes a particular food. Parenting is going to determine whether or not you can convince the kid to eat foods that they don't like. The flip side is you shouldn't ask your kids to do something you're not willing to do yourself, right? So you can't say, I like this food and therefore you have to eat it. Right? Unless you're willing to find healthy foods that your kid likes and eat those even if you don't like them. It has to go both ways. Like a lot of parents are like, I'm not picky about what I eat. Well, yes, you are. You're the one that's writing the menu. You decided what to eat. You picked the foods based on whether or not you like them. Okay? You should pick some foods that your kids like, even if you don't like them. Especially if they're healthy. If there's a vegetable that your kid likes, serve it all the time, even if you don't like it. Learn to like it. Dengue virus in California. It's not right. It's not previously there in California. Yeah, we really need to just sanctify all of the mosquitoes that bite humans. It's like 5 out of 3,000. We can just get rid of them. It'll be fun. Just had COVID. Do I have to wait to get vaccinated? No, I don't think so. Okay, well, there's the argument that you shouldn't go get vaccines while you're sick, both from the point of view of you shouldn't be going out while you're sick because you're contagious, and also because your immune system is busy, so let it spin back down. Go get them all the vaccines. Get your boosters. There's no evidence that getting them more than once is, so you might as well. Just get them every year. Get them twice a year. It's fun. This one is different. Endurance exercise can get rid of body fat even without weight loss. This is, by the way, not practical for most people. This is like marathon runners and English Channel swimmers. So if they only gain 1% muscle, they lost 9% body fat. What was the other weight? Yeah, I mean, muscle is a little bit faster. It's not 9 times faster. On the other hand, if they started out with a lot more muscle, right, so if they, if they started out with, say, 10 units of fat and 100 units of muscle. They're losing 9% of 10 units, right, is 1 unit-ish. And gaining 1% of 100 is 1-ish. So, yes, I guess it's right. And keeping in mind that these were people who were able to ride an average of 100 miles a day on a bicycle. Right? That's quite a lot. So they were pretty healthy to start out with. So they were probably already mostly lean muscle and not that much body fat. But it's interesting that it was focused, the loss was focused on the fat around organs, which is the fat around your organs and in your belly, your little beer belly that you get as you start to get older. Those are more dangerous than the regular fat that's just under your skin. Right? You have fat cells spread throughout your body, and they're useful. You need a certain amount of fat to be healthy, but you want to minimize the fat under your internal organs because it's bad for them. Doctors issue warning over CrossFit challenges. South Carolina women's biceps explode. Explode is not the right word. There are several ways you can hurt yourself. That's not. This is something we've known for a while. It's regular painkillers that you buy off the shelf at your pharmacy or grocery store are basically just as good as expensive, fancy specialty medicines. Even as good as opiates in most places. So, morphine is not really a better painkiller, it just gives you a sense of not caring about the pain as much. But that comes with heavy addiction costs. So, for the most part, if you can get by with just regular old grocery store painkillers, you should do so. Save money and avoid lots of complications. Mm. You should probably not take weight loss drugs without talking to your doctor first. Price versus quality. That's a difficult argument, because we've got supply issues, right? The demand is higher than this. And the main problem is that a lot of these drugs also double as treatment for people with diabetes. That's the word. Completely blanked out on diabetes for a second. Diabetes medications. So it's important to prioritize people with actual life-threatening conditions over people who want to use it to lose weight. And then amongst people who want to use it to lose weight are people who have actual reasons why they're struggling to lose weight, as opposed to people who just can't bring themselves to eat a healthy diet. Right? Because these drugs make you feel bad when you eat too much, is really what they do. So they help you if you struggle to maintain a healthy diet. These will kind of force the issue, because they make you feel like crap when your blood sugar goes wonky. Yeah, enteroviruses have not gotten a lot of news, but they're not good. They're bad news when they do show up. It's good luck, guys. But there's nothing any of us can do about that, I don't think. It's fine. That's why I mostly want articles that are actionable. I feel bad. But right, there's no action that I can take based on this. Right. And this is, the same old ridiculous self-treatment stuff. Drink a spoonful of vinegar. I mean, sure, apple cider vinegar is nutritious. It's a fermented product. I don't know that Acetobacter is useful to our microbiome. but everything that says drink a spoonful of cider or add a spoonful of turmeric, curcumin. Curcumin is the biologically active molecule in turmeric that you think might actually be useful, but there's not enough of it in turmeric to do it good. Also, turmeric has a nasty history of high lead content, so you gotta be careful of that too. Yeah, this is something frustrating too. Every once in a while, people with chronic medical disorders, they go into remission or even get cured. Uh, right, and then the insurance companies are like, "Well, you're no longer disabled. Good luck, bye." And you're like, I've been in trouble for years, insurance company. Just because the root cause has been fixed now does not mean that I don't still need recovery. It's just, although this lady's case, it seems there's a lot of secondary problems that have cropped up. Yeah, transplants of any kind are really difficult. See, that's the nice thing about CRISPR treatments is that they don't require a donor. And eventually they may get cheap enough that they have broad access. $2.2 million. That would be a tough bill to pay. I can't afford that. I'm solidly in the 90 plus percentile. I'm in the top 10%. I'm not in the top 1%. Last I checked, I was 96%. So the top 4%, 60%. But there's no way that a medium income could pay 2.2 anywhere. There's nowhere where that's within lower middle class range. It's just that country doesn't exist. If it does, let me know. I want to move there. So this is interesting. Is if you're getting publicly funded healthcare, right? The idea that it might be cheaper to pay for the gene therapy early on than it is to pay for your healthcare for your whole life. Right, so that's an interesting take on it. Yep. It's tricky. Yeah, and the other thing to remember is that every gene therapy is different. Right? So every single one is going to have to be evaluated for long-term effects. This is something we didn't know at the time. In the 80s and 90s, we didn't know how food allergies develop. So there was a recommendation put in place that kids should not be exposed to common allergens. Since then, we've discovered, and I'd say since then, but also because of that, right, we've discovered that not being exposed to foods when you're really young is one of the causes of developing food allergies. So, turns out it's better to expose infants and toddlers to small doses of all the different foods early on and get their immune systems used to them. But talk to your pediatrician. Yeah. Pediatricians now should be giving different advice. The current advice, at least last I heard, was small doses of a wide variety of foods early on to get the immune systems used to them so that they don't develop allergies. It's interesting. Which worms, though? I mean, yes, and I would probably prefer to take a supplement than actually host parasitic worms in my digestive system. So it's a nematode. Makes me wonder if we could. Makes me wonder if we could breed less harmful versions of these parasites. Make them more symbiotic. Oh, yeah, well, sometimes you snack. I know what time you had your lunch, and I know what time you get your snack. Yeah. And you're right. You're right, silly cat. You're right. It's almost time, but it's not. Silly goose. Mm-hmm. Mm-hmm. Silly goose. Silly boy. I also wonder if we could, for instance, genetically modify a bacteria to produce these chemicals. Right? I doubt that. I doubt that farming nematodes and collecting it is a good way to collect this chemical class. This seems like pretty good evidence that the molecules are there. Something in this, something in these secretions are useful. So, let's see. Full secretion work, heat treated or proteinase treated versions worked. So proteinase would break up proteins. Heat has a tendency to denature all sorts of large compounds. So if it still worked after those treatments, then that puts the focus on the small molecules. The small molecules is most people, when they say chemicals, they're talking about small molecules. They're generally not talking about proteins. Proteins are quite large. That's molecules go. Very complicated too. So they heat treated it, and then filtered out the small molecules and found that still had strong effects. And they cross-referenced a bunch of different horny boys. And they found that the wormy boys had a handful of chemicals that they all produced. So that's interesting. And they synthesized Scaricide number 7. And found that was roughly as good. Interesting. So Scaricide number 7 seems to be very promising. Wonder how difficult it is to make them. This is the details. Okay, so it seems like Scaricide number 1 and 7 were common, but 7 was the one that seemed to have better results. Yes, I hear you. I hear you. Can you wait 10 minutes? Yeah. Bedtime's in 10 minutes. Yeah. I'll probably sign out. Yeah, this is a thorough and productive example of seeing a natural effect and trying to isolate it. Nope. They don't treat an allergic reaction that's already in progress. That's interesting. They get in ahead of time and they affect the expression of some of the prefactors of the T-cell response. That's interesting. Is your weight healthy? Mine's okay. I've lost a reasonable amount of weight so far in my diet, but it's really kind of plateaued. I'd like to ditch a bit more. I could still stand to lose a decent amount of weight. So I've got a ring of belly fat that I need to get rid of. Because like I was saying earlier, belly fat and fat around your organs is dangerous. However, I'm not yet in enough shape to do. Super endurance exercise. I can't run a marathon, and I doubt I could do 100 miles a day on a bike. Sure. Did buy myself a rowing machine and gradually raising the amount of time that I spend every day rowing. This is actually an interesting question. Call for better dose control. And that's effective. Let's play one game of team. 3, and 6. Okay, stack. Okay, sign off. One is too small, 2 is too small. 6 is 6. Difference in blue bars. 1 plus 5, 2 plus 6. Okay, so we don't have any of those. It's 3. So we definitely have a 3 in one of these. There's 12. One is too small. So either 3 and 3 and 4 is not leaving. Can't put 3 by 3 by 6. Mm-hmm. One, two, 5, 6. So he's up 5. 6 is no. This 1 requires 2. 2 measures 4. 3 requires 6. 4 would require 2. 6 takes 3. Okay. Let's see. This 1, 3, 4 is 6, 4, 3. So it's to 7. Okay, so 1 pairs with 3, 3 pairs with 1, 5, 4 pairs with 6. Super informative. That's fine. 6. 6. 6 is 1, 2, 3, 6. 6, 1, 2, 3, 6, 1, 2, 3, 6, 1, 2, 3, 6. So this one is 4. This one is 5. Excellent. That's the 4 and the 5. This is the only one that has a 4. Because this one can't have the 4. And none of these have the 4, which now makes this one the only one that has the 5. So this 1, this is 5, that's the one. I know this one has to be odd since it's not even. So an even number plus an even number is also an even number. Which means I need to have an odd number to make it happen. Mm. That was six, seven, that's the two, that's the four, that's the requires a second. It's 4, 6, 1, 6, 7, 3, 6. So 3, that's 3 and 6. One goes with 6, 2 goes with 3. So we have 1, 5. So 2 requires 5. So 2 requires 3. This is 2. This is 6. So this is going to be 4. So it's 4, 1. So let's see, here we have 2, 3, 4, 2, 5, so that's not good. So that's 2, that's 3, that's 6, 1, 2, 6. 6 minus 2 and 4, 5 to 6, plus that's 5. 2 there, so that's 4, 2, 6, 6, 4, 4, 3, 6, 3, 6. So I'm going to sign off. I'm going to go get my buddy snack. He's being very good and patient, staring at me. But he's not. He's not pestering me, so he's being good. And I'll let that. I'll see you later.